Chemistry, the magical world where atoms mingle and molecules dance. Picture this. You've got your periodic table, a smorgasbord of elements just waiting to mingle and make magic happen. Oxygen and hydrogen? They're like the ultimate power couple teaming up to create water, the elixir of life, and the perfect excuse for a refreshing dip. But wait, there's more. Let's talk about acids and bases, the dynamic duo of the chemical world. They're like the odd couple, constantly bickering and yet somehow creating the most deliciously fizzy reactions. Just add a splash of acid to a base, and voila, you've got a bubbling concoction that'll make your taste buds tingle and your eyebrows raise. Now, let's not forget about everyone's favorite party trick: chemical reactions. It's like throwing a bunch of ingredients into a cosmic blender and watching the fireworks fly. From explosive reactions that leave you breathless to slow-burning romances that simmer and sizzle, chemistry is the ultimate matchmaker. But hey, let's not get too serious after all. Chemistry is all about having fun with atoms and molecules. So grab your lab coat and safety goggles, and let's dive into the wacky world of chemical bonding and electron sharing. Whether you're drawing Lewis structures or balancing equations, just remember, in the world of chemistry, anything is possible and everything is hilarious. Now, let's break down a couple of chemical formulas for good measure. Picture a big, bold H2O, that's water, folks, the stuff of life and the ultimate thirst quencher. And how about a little CO2 action? That's carbon dioxide, the fizzy stuff in your soda, and the gas you exhale with every sigh of relief. So there you have it, a humorous romp through the wild world of chemistry. Just remember, when in doubt, add a dash of sodium and see what happens. Chemistry, it's a gas. Embrace the chance to study now, as your success solely depends on you. Seize the opportunity and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will. Organic chemistry, the study of carbon-based compounds, is a fascinating field filled with endless possibilities. From the molecules that make up our bodies to the compounds that fuel our cars, organic chemistry plays a vital role in our everyday lives. Let's delve into some key concepts and equations to further our understanding. 1. Topic: hydrocarbons. Example: ethane, C2H6. Explanation: ethane is a simple hydrocarbon consisting of 2 carbon atoms, bonded together with single bonds and 6 hydrogen atoms. Its molecular formula is C2H6. Each carbon atom forms 4 bonds, saturating its valence shell. The structural formula for ethane can be represented as H3CCH3, indicating the single bonds between the carbon atoms and hydrogen atoms. Exercise 1. Write the structural formula for propane, C3H8. Explanation: propane, another hydrocarbon, consists of 3 carbon atoms bonded together in a chain with 8 hydrogen atoms. Each carbon atom forms 4 bonds, so the structural formula for propane can be represented as H3CCH2CH3. 2. Topic: functional groups. Example: ethanol, C2H5OH. Explanation: ethanol is a compound containing a hydroxyl O functional group attached to a carbon atom. Its molecular formula is C2H5O. The presence of the hydroxyl group makes ethanol a member of the alcohol family. The carbon atom in the hydroxyl group is bonded to 1 hydrogen atom and 1 oxygen atom. Exercise 2. Identify the functional group present in methanoic acid, HCOOH. Explanation: methanoic acid, also known as formic acid, contains a carboxyl CU functional group. This group consists of a carbonyl group, C=O, and a hydroxyl group, O, bonded to the same carbon atom. The presence of the carboxyl group makes methanoic acid a member of the carboxylic acid family. 3. Topic: Isomerism example. Butane, C4H10. Explanation. Butane is a hydrocarbon with the molecular formula C4H10. It exists in two isomeric forms, N-butane and isobutane. N-butane, also known as normal butane, has a linear structure with 4 carbon atoms in a straight chain. Isobutane, on the other hand, has a branched structure with 3 carbon atoms in a chain, and 1 carbon atom branching off. Exercise 3. Draw the structural formulas for the two isomers of pentane, C5H12. Explanation. Pentane has 3 structural isomers, N-pentane, isopentane, and neopentane. N-pentane has a linear chain of 5 carbon atoms. Isopentane has a branched structure with 1 methyl group, CH3, branching off from the second carbon atom, and neopentane has a fully branched structure with 4 methyl groups attached to a central carbon atom. By applying these equations and concepts, we can deepen our understanding of organic chemistry and its importance in various fields of science and industry. Organic chemistry is the backbone of modern science, and understanding its principles unlocks a world of possibilities. Let's explore 3 key topics in organic chemistry and dive into some examples and exercises to solidify our understanding. 1. Hydrocarbons. These are the simplest organic compounds, consisting of carbon and hydrogen atoms. Let's take ethane, C2H6, as our example. Ethane is a straightforward hydrocarbon with 2 carbon atoms bonded together and 6 hydrogen atoms. Its structural formula, H3CCH3, illustrates the single bonds between the carbon atoms and hydrogen atoms. Exercise 1. Write the structural formula for propane. C3H8. Propane, with its 3 carbon atoms and 8 hydrogen atoms, can be represented as H3CCH2CH3. 2. Functional groups. Functional groups are specific arrangements of atoms within molecules that impart unique chemical properties. Consider ethanol, C2H5OH, which contains a hydroxyl O functional group attached to a carbon atom. This functional group makes ethanol a member of the alcohol family. Exercise 2. Identify the functional group present in methanoic acid, HCOOH. Methanoic acid contains a carboxyl COO functional group consisting of a carbonyl group, C=O, and a hydroxyl group, O, bonded to the same carbon atom. 3. Isomerism. Isomers are compounds with the same molecular formula, but different structural arrangements. Let's look at butane, C4H10, which exists in 2 isomeric forms, N-butane and isobutane. N-butane has a linear structure with 4 carbon atoms in a straight chain, while isobutane has a branched structure with 1 carbon atom branching off. Exercise 3. Draw the structural formulas for the 2 isomers of pentane, C5H12. Pentane has 3 structural isomers, N-pentane, isopentane, and neopentane, each with distinct arrangements of carbon atoms and methyl groups. By mastering these fundamental concepts and completing the exercises, you'll deepen your understanding of organic chemistry and its applications in various scientific disciplines. Keep exploring, and remember, chemistry is the ultimate puzzle waiting to be solved.